Directive influence of functional groups in monosubstituted benzene. Consider a monosubstituted benzene, means benzene which contain only one substituent. This is benzene molecule. Let the substance be A. So A can be any atom or group. It can be any functional group or any substituent. This is a monosubstituted benzene. We know with respect to this substituent, the adjacent positions in the benzene ring, that is, if this is carbon number 1, 2, 3, 4, 5, 6, with respect to the substituent which is present in the benzene ring, these position 2 and position 6 or 1, 2 positions are ortho to one another. So this position is ortho. This position carbon number 6 also ortho, that is the adjacent carbon atom to which the substituent is attached. These two carbon atoms are called ortho carbon or ortho position, and the position 1 and 3 and 1 and 5 are called meta position. There are two meta positions, and the position 1 and 4 means 1, 4 positions are said to be para to one another. This is para position. So with respect to the substituent, we have ortho, meta and para position. If this monosubstituted benzene undergo further substitution reaction, for example, an electrophilic substitution reaction, means an electrophile attack. An electrophile, we know electrophiles are positively charged. Benzene ring is electron rich because it contains 6 pi electron, right? 3 pi bond, so total 6 pi electron. Benzene ring is electron rich. It can be readily attacked by electron deficient species or electron seeking species, which are called electrophiles. So E plus is an electrophile. This monosubstituted benzene undergo further substitution by an electrophile. So for this electrophile to attack on the benzene ring, there are 3 possibilities. The electrophile can either attack the ortho position, meta position or para position. So there is a possibility of 3 products. The substitution, if the substitution of the electrophile takes place in the ortho position, we get a product. That is, the electrophile attack the ortho carbon atom and substitute the hydrogen present in the ortho carbon. Hydrogen atom present in the ortho carbon atom substituted by the electrophile. That is, the electrophile attack the ortho carbon and substitution takes place in the ortho position. This is called ortho substituted product. If the substitution takes place meta position, if the electrophile attack the meta position, we get the product here, electrophile attached to the meta carbon atom. Substitution takes place in the meta position. There is one more possibility, that is, if the electrophile attack the benzene ring in the para position. Electrophile substitute the hydrogen atom present in the para carbon atom. So 3 products are obtained. Ortho, this is meta product, this is para disubstituted product. The product formed, whether ortho, meta or para, depends on the nature of the substituent which is present in the benzene, that is A. A determine which product will be obtained, in which position the electrophile would attack and which product will be formed, decided by A. So depending upon the nature of A towards this substitution reaction, 2 types of behavior are observed. One type of substituent. We have substituents, here we have written A. There are of 2 types. One type of substituents are called ortho-para directing ortho-para directing group. Ortho-para directing groups. And the other one is called meta-directing groups. Ortho-para directing group means these substituent will direct the incoming group, here electrophile, incoming group towards ortho position and para position. That means we get two products, ortho substituted product and para substituted products are obtained. There are some groups which will direct the incoming group towards ortho position and para position. And we get a mixture of ortho product and para product. Such groups are called ortho-para directing groups. But there are some other type of substituents which will direct the incoming group, incoming electrophile towards meta position. Such groups are called meta-directing groups. Example also we can give. Examples of ortho-para directing groups are OH group, amino group, NHR, secondary amino group, then OCH3, alkyl group, CH3, C2H5. All these groups, if present in the benzene ring, the further substitution takes place in ortho position and para position. We get mixture of ortho disubstituted product and para substituted product. So these are examples of ortho-para directing groups. Meta-directing group examples are nitro group, cyano group, aldehyde, carboxylic acids, sulfonic acid group, esters, COOR group. These groups are examples of meta-directing group. Why this distinction? Why some groups? Why these groups give ortho-para substituted product? Why these groups give meta-substituted product? We will explain. See, and these substituents are further classified into two types. The substituent which is already present in the monosubstituted benzene again classified into two types depending upon their behavior towards the attack of electrophile. There are substituents which when attached to benzene ring, the electron density of the benzene ring is increased. There are substituents which can increases the electron density of benzene. Such groups are called electron donating group. If the substances are electron donating group, they increases the electron density of the benzene ring. So the attack of electrophile takes place more easily. If the benzene ring is more electron rich, the electrophile can attack the benzene ring more readily. Such groups are called ring activating group. They activate the benzene ring towards the attack of nucleophile. Generally, ring activating groups are ortho-para directing group. Means these ortho-para directing groups, these are examples of ring activating group also. Ring activating groups are generally ortho-para directing groups. They activate the benzene ring towards the attack of electrophile. How they activate the benzene ring? They increases the electron density of the benzene ring because they are electron donating groups. Electron donating groups, if present in benzene, They donate electron towards the benzene and increases the electron density of the ring. And such groups activate the ring towards electrophilic substitution reaction. Such groups are called ring activating group. Ring activating groups are ortho para directing group. So these are all ortho para directing group. These are all electron donating groups. EDG. Now the second behavior of certain groups are electron withdrawing groups. There are certain substituents which are electron withdrawing in nature. So when such groups is present in the benzene ring, electron density, these electron withdrawing groups decreases the electron density of the benzene ring. When benzene ring contains such groups, electron density of the benzene ring is reduced. So electrophilic attack of the electrophile on the benzene ring is reduced. Means such groups deactivate the benzene ring towards the attack of electrophile. Such groups are called ring deactivating groups. Generally, ring deactivating groups are meta-directing. Ring deactivating groups are meta-directing. That means all these groups are deactivating group. Examples of deactivate. When these groups present in benzene ring, electron density of the benzene ring will be reduced. Attack of the electrophile will become more difficult. Hence, they are deactivating group. And they are also meta-directing group. The incoming electrophile will be directed towards meta position. So these are examples of ring deactivating group and meta-directing groups. So the substituents which is present in benzene ring are of two types. They are either electron donating groups or electron withdrawing groups. If electron donating groups, they are ring activating groups and are ortho para directing groups. If the group attached to the benzene ring are electron withdrawing groups, they are called ring deactivating group and they are meta-directing group. These are the examples. Now let us explain why. What is the reason why electron donating group activate the benzene ring? Why they are ortho para directing? Why electron withdrawing group? How electron withdrawing group deactivate the benzene ring towards electrophilic attack? And why they direct the incoming group towards meta position? We can explain on the basis of electron displacement effect. Let us explain with example. So depending upon the nature of the substance, if the benzene ring contains an electron donating group, if the group present in the benzene ring is an electron donating, it would donate the electron towards the benzene ring. So electron density or electron richness of the ring of benzene ring increases. Benzene ring becomes more electron rich. That means it activate the ring towards electrophile, towards attack by electrophile. They are called ring activating groups. Such groups are called ring activating groups. And these ring activating groups are generally found to be ortho para directing. Means they direct the incoming electrophile. If there comes an electrophile, this electrophile will be directed towards ortho position and para position. So we get two products. If the electrophile, so these group direct the electrophile toward the ortho position. Substitution takes place in ortho, electrophile attack the ortho position and we get a ortho product. Ortho disubstituted product. If the electrophile is directed towards para, we get the other product in which the para carbon atom attacked by the electrophile and we get para-substituted product. This happens when, so here we get para-disubstituted product. We get a mixture of ortho and para-substituted product if the group attached to the benzene ring is electron donating. It is ring activating group and ortho para directing group. Examples examples are OH group, NH2 group, secondary amino group, OCH3 group, alkoxy group, alkyl groups like methyl, ethyl. All these are examples of electron donating groups. They are ring activating groups, ortho para directing. If these groups present in benzene ring, ortho and para product, mixture of ortho and para products are obtained. In the same way, if the group attached to the benzene ring, is electron withdrawing, if the benzene ring contains an electron withdrawing group, EWG is the substituent, it would withdraw the electron density from the benzene ring. It would take away the electron density from the benzene ring. So here the electron flow is just the opposite, from the benzene ring towards the electron withdrawing group. So what happens? Electron density of the benzene ring decreases. Electron richness of the benzene ring decreases. That means the electrophilic attack will become more difficult. Means such groups deactivates the ring towards the attack of electrophile, because the ring is less electron rich now. So an electrophile cannot come and readily attack. Such groups are called ring deactivating group. Such groups are called ring deactivating groups. They are found to be generally these groups, deactivating groups, are found to be meta-directing. That is, when an electrophilic, if the electrophilic attack is difficult to occur because this group is ring deactivating group, electron density of the benzene ring is reduced, hence the attack of electrophile is difficult here. And if the electrophilic reaction takes place, what happens? This group will direct this electrophile towards the meta position. So we get meta-substituted product. Substitution takes place. The electrophile attack the meta-carbon atom and substitute the hydrogen. Meta-hydrogen, the hydrogen present in the meta-carbon atom substituted by the electrophile. If an electron withdrawing group, which is ring deactivating, meta-directing group, we get meta-substituted product is obtained. Examples of these groups: nitro group, cyano group, SO3H group, aldehyde, carboxylic acid group, ester, COOR. All these are examples of electron withdrawing group. They are ring deactivating group, meta directing groups.